Let us solve the second paper of our second internal test, which was also an MCQ based paper. So our first question is, which of the following is an example of Gaussian quadratic formula for numerical integration? A. Trapezoidal rule, Simpson one-third rule, Simpson three-eighth rule, and Gauss-Legendre quadratic. So its answer will be D, because from numerical integration we derive this formula first, and by putting the value of n equals to 1, 2, 3, we find a form we find trapezoidal formula, Simpson one-third rule, and Simpson three-eighth rule from Gauss-Legendre quadratic formula, right? Here we can see in this image how we have derived it. So let us consider a function fx, which we have to integrate from a to b. So let us take x equals to a plus hu. So what will be dx? Dx will be h du, right? So if we find the points, it will be 0, and here it will be h, right? So what would integration would become? I will become h integration 0 to h f of a plus hu du, right? Now we will expand it by Taylor's theorem. As we know Taylor's theorem, this function will become I equals to h integration 0 to h fa plus u upon factorial 1 forward difference of operator fa plus u into u minus 1 upon factorial 2 del square fa, and so on. Now what we can do is we can integrate all of these terms. So fa will become ufa, u upon factorial 1 will become u square upon 2. Similarly, these terms will become this, and these terms will become these, right? So now we can replace u by n. So I will become h n fa plus n square del fa, and so on. So quadratic Legendre formula, from these we can uh, take n common. So our final formula will look like this, that is I equals to nh fa plus n upon 2 del fa plus 1 by 2 n square upon 3 minus n by 2 del square fa, and so on. Now from here, if we want to find the value of let us say Simpson one-third rule or trapezoidal rule. For trapezoidal rule we will put n equals to 1. For Simpson one-third rule we will put n equals to 2. For Simpson 3 by 8 rule we will put n equals to 3, and we will get this formula, right? So which of the following is a Gaussian quadratic formula for numerical integration? It will be Gaussian Legendre formula. Now let us see the second question. Which of the following is true regarding the weights and abscissa used in Gaussian quadratic formula? The weights and abscissas are equal in number. Yes, this is true, because in a Gaussian quadratic formula we divide it in terms of a plus hu, right? So each and every term gets this number. So weights and abscissa are equal in number. This is true. The rest of the formula are weight and abscissa are not equal in number. No, this is not. The weight and abscissa are the same for all orders of formula. No, these values can change, right? So the weight and abscissa are equal in number. This is true. Let us solve question number 3. What is the accuracy for Simpson 380? So first of all we need to understand what is accuracy. Accuracy means the highest degree order polynomial Simpson 3a tool can solve, and as we know, it can solve maximum of degree 3 polynomial. It can solve polynomial of maximum 3 degree, so it will be C3. Here we can see it as well. When we want a Simpson 3a tool from quadratic formula, we put n equals to 3 to generate this formula. So it will be 3h fa plus 3 by 2 del fa plus 3 minus 3 by 2, and if we solve this, we will get this formula 3h by 8 y0 plus 3y1 plus 3y2 plus y3. And for more terms, it will be like this, and if we add all, we will get this general formula I equals to 3h by 8 y0 plus yn plus 3 y1 y2 y4 y5 y7 y8, that is yn minus 2 plus n minus 1 terms, and all the odd terms multiplied by 2, all the multiple of 3 multiplied by 2, right? So its answer would be 3. Let us solve the question number 4. Which of the following is an example of composite integration method? A. Trapezoidal rule, B. Simpson-Wurter rule, Gauss-Legendre quadrature, or both A and B. So what is composite integration rule? Let us see that. The composite integration method is also known as numerical integration or approximation method. It is a numerical technique used to approximate the definite integral for a function over a given interval. The method involves dividing the integration interval into small subsequences and approximating the integrals over each subinterval using subinterval formula. The result of these approximations are combined to obtain approximation of the total integral over the entire range. Its examples are trapezoidal rules, Simpson rules, and midpoint rules. These methods are widely used in numerical analysis and computational science integration that are difficult or impossible to evaluate analytically. So what we have asked, which of the following is an example of composite integration method? So it will be both A and B's, trapezoidal rule and Simpson-Wurter rule. Let us solve question number 5. What is the drawback of using higher order Newton-Cotes formula for numerical integration? A. They are less accurate than low order formulas. They require more function evaluation. They are not applicable to non-smooth functions. And D. None of the above. So in Newton-Cotes formula, abscissas are divided equally, right? So if abscissas are divided equally, so the higher order function takes more abscissas and their calculation becomes more tougher. So its answer should be they require more function evaluation. In higher order, we require more function evaluation because they take more abscissas and it gets difficult to solve. So they require more function evaluation. So answer would be B. To question number 6. Which of the following is true regarding the abscissa used in Gauss-Legendre quadrature? They are equidistant, they are non-equidistant, they are dependent on the order of the formula, none of the above. So like a Gauss quadrature formula, Gauss quadrature formula they are also equidistant. So answer will be A. They are equidistant. Let us proceed to question number 7. Which of the following is an example of open Newton-Cotes formula for numerical integration? Trapezoidal rule, Simpson-Wurter rule, Simpson-3a rule, both B and C. So this question is repeated from previous question. I think it was last question paper, question number 20. So it has been repeated here. So you can see there, or I am explaining in brief here as well. So this is our formula for Newton force, that is I equals to nh summation I equals to 0 to n yi ci raised to the power n, where this ci raised to the power n is Cotes number, and it can be expressed as 1 by n integration 0 to n li u du, right? And what is li here? Li is the Lagrange's interpolation, which can be expressed like this. Okay, so for Simpson one-third rule, we put n equals to 2 in this formula and we solve this. So 2h summation I equals to 0 to 2 yi ci square. Now we will find what ci square's values. So ci is 0, we will find ci c0, c1, c2. So c0 would be what? U minus 1, u minus 2 upon 0 minus 1 upon 0 minus 2. Similarly, we will find c1, c2, right? And we will put the values 0 to 2, 0 to 2, 0 to 2 here. And we will solve this and we will get what values? 1 by 6, 4 by 6, 1 by 6. And we will put these value in this term and we will get our Simpson one-third formula, right? Now we could apply same these methods for Simpson 3a rule. Just put n equals to 3 and solve, and we will get Simpson 3a2. So yeah, it will be both Bn's. What is forward difference operator? It approximates the derivative of a function using the values of the function at two neighboring points. It approximates the derivative of a function using the values of a function at three neighboring points or four neighboring points or none of the above. So let us write the forward difference operator. So forward difference operator is what? Fx equals to f of x plus h minus fx, right? So it works on two neighboring points, right? As we could see, x plus h minus fx. So it works on two neighboring points. The answer would be what? Two neighboring points, that is A. So 8 answer would be A. Let us proceed to question number 9. What is backward difference operator? It approximates the derivative of function using the value of a function at two neighboring points, three neighboring points, four neighboring points, and none of the above. So let us write the backward difference operator, that is nebula fx equals to fx minus f of x minus x, right? So as we could see, it is working on two neighboring points. So answer should be A. It approximates the derivative of function at the two neighboring points. So answer would be A. Let us proceed to question number 10. What is the divided difference operator? It is used to approximate the derivative of function at a given point. It is used to interpolate a function at a given point. It is used to approximate derivative of a function using the values of a function at multiple neighbor points, or D, none of the above. So let us see what is divided difference operator. So divided difference operator is this, that is f of x1 comma f2 equals to f of f2 minus x1 upon x2 minus x1, and for this it would f of x3 comma f2 x2 minus f of x2 minus x1 upon x3 minus x2. So it is nothing but option number C. It is used to approximate the derivative of a function using the values of a function at multiple neighbor points. As you can see, these are the multiple neighbor points which we are using in divided difference operator. So answer would be C. Let us proceed to question number 11. What is shift operator? It shifts the values of a function to left or right. It approximates the derivative of a function using the values of the function at a multiple neighboring points. It is used to interpolate a function at a given point and the none of the above. So what is shift operator? Shift operator means e raised to the power n fx can be written as f of x plus nx, right? So what does it do? It shifts the value of a function right or left. So option A will be correct. Let us proceed to question number 12. What is the order or accuracy of Simpson 130? So accuracy means up to which highest degree the polynomial can be integrated. So in Simpson's one-third rule, it will be 2 because let's see with quadratic formula. From quadratic formula, if we want to derive Simpson one-third rule, we put the value of n equals to 2, right? So that we could find the value of Simpson one-third formula. So when we put 2 in this formula, we will get 2h equals to fa plus del fa plus 1 by 2 4 by 3 minus 1 upon del square f. And when we simplify it and add all the terms, we will get I equals to h by 3 y0 plus yn plus 4 times of odd terms plus 2 times of even terms. So answer will be 2. Let us proceed to question number 13. Which of the following numerical integration method is based on the use of forward difference operator? Trapezoidal, Simpson, one-third rule, none of the above. So let us see the formulas of all these terms. So in trapezoidal formula, you can see we are not using forward difference operator. So trapezoidal is not the answer. Simpson one-third rule as well, we are not using a forward difference. And in midpoint rules, we are also not using forward difference operators. So answer will be D, none of the above. Let us proceed to question number 14. Which of the following numerical integration method is based on the use of backward difference operator? Trapezoidal, Simpson, or midpoint rule, or none of the above? So let us see the formulas for each option. So in trapezoidal rule, we are not using backward difference operator. So trapezoidal rule cannot be answered. In Simpson one-third rule, we are also not using the backward difference operator, so it can't be answered. And in midpoint rule, we are also not using the backward difference operator, so it also cannot be the answer. So answer will be D, none of the above. So answer will be D. Let us proceed to question number 15. Which of the following numerical integration method is based on a central difference operator? Trapezoidal rule, Simpson rule, midpoint rule. So let us see the formula. So here we are not using midpoint rule, so trapezoidal rule cannot be answered. In Simpson one-third rule, we doesn't use midpoint rule, so it also cannot be the answer. And in midpoint rule, we can clearly see we are not using the midpoint rule, so it also cannot be the answer. So answer will be D, none of the above. Now let us proceed to question number 16. Which of the following numerical interpolation formulas is based on a divided difference operator? So from starting we are studying that it is Newton dividend difference formula, so it will be A. Now let us proceed to question number 17. Which of the following numerical interpolation formulas uses the polynomial interpolation? So yeah, we are studied before that Newton dividend formula uses a dividend formula, while Lagrange's interpolation uses polynomial interpolation. So it will be B. B would be the answer. Let us proceed to question number 18. Which of the following numerical interpolation formulas is used for interpolating a function with both its values and derivative at a given point? So it cannot be Newton dividend formula, it cannot be Lagrange's interpolation formula. It is Hermite interpolation formula. So what is Hermite interpolation formula? It is nothing but the extension of Lagrange's interpolation, where we are given both its values and derivative of that given point, so that we could find more complicated and more complex answers. So it would be C, Hermite interpolation. Thank you. Let us proceed to question number 19. Which of the following is true for a numerical integration methods based on a higher order polynomial? They are more accurate for those based on a lower order polynomial. They are less accurate than those at a lower order polynomial. They are equally accurate as those based on lower order polynomial. None of the above. So it should be A. They are more accurate than the lower based on a lower order polynomial, because in lower order polynomial the the calculation is easier, but we cannot find the more accurate answer. So it should be A. They are more accurate than those based on lower order polynomial. Let us proceed to question number 20. Jacobi method is also known as. So Jacobi's method is also known as simultaneous displacement method. It must be remembered that Jacobi's method is also known as simultaneous displacement method. Thank you. So with this question, we have completed both our first and second internal paper solutions. So thank you.